Pretty cool.
Okay, so we would like to compute this W integral over D, where D is the part of the disk of radius 2, centered at the origin that lies in the first quadrant. Let's actually draw D and understand what we're dealing with here. So suppose that this has radius 2, and this is D. And this can be very conveniently described in polar coordinates in a very simple way. The radii are between 0 and 2, and theta is between 0 and pi over 2. Now, in order to turn this integral to switch to polar coordinates, we first need to know the domain, which is precisely what we just did. So by knowledge of this domain, we can actually have a the double integral, or rather the limits of it, written right away. So this will be 0 to 2 dr and 0 to pi over 2 d theta. And then our second the second thing that we should do is express the integrand, which is xy, in terms of r and theta. So for that, let's recall that x is equal to r cosine theta and y is equal to r sine theta. So this will give us r cosine theta times r sine theta. And the third step that we should never forget is to multiply by the Jacobian, which accounts for pretty much for the areas of the polar rectangles. And that's our integral. So now once we have that integral, it should be pretty straightforward to compute it. So let's simplify it a little before we start our computation. So we're dealing with r cubed cosine theta sine theta. Oops, let me rewrite this. So first, let's do 0 to 2 dr. So that will be our inner integral. And then 0 to pi over 2 d theta. So I'm going to do the integration first with respect to r. So this will give me r to the 4 over 4 cosine theta sine theta. And here I will go from r equals 0 to r equals 2. Integral from 0 to pi over 2 d theta. And that will be, when I plug in r equals 2, I will get 16 over 4. So that gives me a 4 cosine theta sine theta. And 0 to pi over 2 d theta. Now here we will do this integral by using a substitution. So u will be sine theta. You can also use cosine theta, it doesn't matter, it's pretty much the same thing. Du is equal to cosine theta d theta. And remember that the endpoints of the integral, the limits of the integral, have to be changed by inserting them into the substitution. So sine of 0 is 0, sine of pi over 2 is 1, and then we will have 4 u du. Okay, cosine theta d theta is r du. Okay, that's a very simple integral. The antiderivative will be 2u squared from 0 to 1, and this is equal to 2. And that's all. Okay, thanks for watching.